Great day learners, welcome back. After a long time I'm just posting this video. I will try to post the videos continuously in the future. And in this video we are going to see the past paper probability and statistics 2. So usually we will call it as paper 6 in the component 9709. 6-2 we are going to solve, and in that the May-June 2024 paper is what that I'm going to solve today. The component is 6-2, the zone 4 code. Let us start solving the problem. Before start solving the problem, we will have to know that the duration of the component is 1 of 15 minutes, and then the maximum mark for this paper is 50 marks. So within 75 minutes we will have to score the 50 marks. Okay, let us start solving the problem. So the first problem is a random variable x has the distribution of Poisson with 145 as the average rate. It means that this problem is from a Poisson distribution. Now let us see what we have to solve in this unit. Use a suitable approximating distribution to calculate the probability of x less than or equal to 150. So we have to do the approximation, and we know that if we have to do the approximation from the Poisson, the approximation actually goes to a normal distribution, and it actually the parameters are lambda comma lambda. So usually the normal distribution will have the parameters mu comma sigma square, where that mean and then variance, but here the mean, which is mu, is also lambda, sigma square is also lambda. If you see in this sense, we can actually write the distribution what we are going to use for solving the problem is going to be normal distribution with 145 comma 145. Means mean is also 145, variance is also 145. And after getting to know about this, the solving is very simple. Since we have to find the probability of x less than or equal to 150, the first thing what we have to do is we will have to apply the normal distribution conditions. So what is the formula that we usually use? It is pi of x minus mu divided by sigma is what we will be using it. But it is an approximation. So approximation in the sense we will have to use the continuity correction. X less than or equal to 150. If x less than or equal to 150, then the value what we will use for x is not x, not the direct value that is 150. We will have to take 150.5. Why we have to add? Because in the actual problem, inclusive of 150 we will have to take. So means 150 must be there. We are not supposed to take 149.5, so which will avoid that 150. But if you are taking 150.5, it definitely takes that 150. It's not that exact definition that I have to give, but it will give you other understanding. Like if it is 150, for the approximation what we have to do for the continuity correction is we should go with 150.5 or else 149.5. Since it is x less than or equal to 150, inclusive of 150, so we should include that 150. In that sense, we should use only 150.5, which will cover the 150. So the x value will be replaced by 150.5 minus mu, which is nothing but 145, whole divided by 1 root of 145, because we have to use sigma, not sigma square. So it is root of 145. And these values, if I'm putting it in the calculator, I will be getting the answer as 0.457. Then I have to use the normal distribution table. For that I have to find the pi of 0.457. The actual value what I will be getting is 0.6761. Since I have to close this problem and I have to give the final answer, this answer should be in the 3 significant figure. So the final answer is 0.676. So first we are identifying the problem is from the Poisson distribution, and since we have to approximate it, we have to know that what approximation that we have to do. It is actually from Poisson to normal. Then after that we should know what is the parameter that we have to do. It is mu and sigma square. I'm writing the value and I'm writing the distribution what I'm going to use. Then I'm just executing the problem. Since it is approximation, I'm applying the continuity correction and I'm applying it in the formula, and it is quite simple. Let us move on to the next problem. The second question is, justify the use of your approximating distribution in this case. So when we are approximating it from Poisson to normal, the condition is, it has actually only one single condition, that lambda should be greater than 15. As what is the answer that you will have to write, because this whatever I'm writing it here is not the main answer, that is for you to understand the problem and then concept. So the answer is lambda, as lambda is equal to 145, which is greater than 15, approximating distribution is justified. Or you can write approximating distribution is valid. That's it. This is the one single line answer that you can give to gain this 1 mark. Actually, the condition from Poisson to normal when we are approximating, the lambda should be 15, but in the problem we know that the value of the lambda is 145, so that approximating distribution is justified here. Let us move on to the next question, which is the problem number 2. Henry wants to choose a random sample from the 804 student at his college. He numbers the student from 101 to 804 and then use the random numbers generated by his calculator. The first 20 random digits produced by his calculators are as follows. So if you see the numbers right from 5, 6, 7, it keeps going till that last 7, 6. Henry's first two student numbers are 567 and 109. Use Henry's digit to find the numbers of the next students in the sample. So just we are relating his digits and then the answers what he has taken, the two numbers. If you see, the 567 is the first 3-digit number that is in the digits. So 567 he chose, and then the next he chose 108. In this case, if we go further, we will have to find the next two students in the sample. I mean, the next two numbers we will have to find. The digit is 843. Maybe you will be writing that as answer, but actually it is not. Why it is not? Because there are 804 students. This is the tricky thing here. It is actually, the problem is very simple, because the digits we are deriving it from the numbers. So if you are writing 843, you may lose marks, because 804 is what the maximum strength, so 843 is not possible. So we are going to the next 3-digit number, which is 109. And obviously 109 has been written already, so we are not going to take that as also answer. So the next answer is 665. So in the next 3-digit, what I'm going to take is 0 to 1. It's 0 to 1 or 21, anything is fine for the first A subdivision. So this is what the digit that he is taking it from the calculator values. So the next thing is, there were 30 students in Henry's sample. He asked each of them how much time X hours they spent on social media each week on average. He summarized the results as follows. N is 30, summation X is 610, summation X square is 12,405. Use this information to calculate an unbiased estimate of the mean of X and show that an unbiased estimate of the variance of X is less than 0.1. So here we have to calculate estimate of the mean of X and then the unbiased estimate of the variance as well. We have to calculate, and then we should prove that the value is less than 0.1. So let us start finding the unbiased estimate of the mean. So unbiased estimate of the mean. the formula for unbiased estimate of the mean is x bar is summation x by n is actual formula, but here we have to substitute the values. Summation x is 610 divided by n value is 30, and the calculator will give us the answer as 20.3 as answer. So we found that unbiased estimate of the mean. So the next thing is we have to calculate the unbiased estimate of the variance. If you have to calculate the unbiased estimate of the variance, the formula is 1 by n minus 1 summation x square minus summation x the whole square by n. There is another formula as well, but actually I usually go with this formula, so I prefer to go with this. So 1 divided by n minus 1, n is 30, so 1 by n minus 1 will become 1 by 29 multiplied by summation x square, which is 12,405 minus summation x. Some of you might be taking this as a mean, so that the previous value might be using it is actually not. Summation x the whole square by n. So summation x is 610, so it is going to be 610 whole square divided by 30. So the entire value, if you use it in the calculator perfectly, we are getting the answer as 505 divided by 87, or in terms of decimal the value is 0.0574. The thing what we have to prove is s square, which is 0.0574, is definitely less than 0.1, hence proved. Maybe if you want you can conclude it with the word hence proved, because the value what we are finding is 0.05, which is obviously less than 0.1. Then the C subdivision is Henry's friend claims that Henry has probably made a mistake in his calculation of summation x or summation x square. Use your answer to part B to comment on this claim. So which one we have to claim? Either with, we found two things, one is x bar and then the another one is variance. If you see here, we actually cannot comment about the mean. Maybe you can even think about the mean. The mean, if you see, it is 20 minutes is what they are spending as an average time for the entire week in each week. But that is also like we can't relate it, but still mathematically if you are speaking, the variance value will be bigger than 0.1. It is not usually going to be 0.1. It is too small. So we are going to say the unbiased estimate variance. We can even add the word unbiased estimate, that entire thing you can add it. Variance is too small here. You can write the value as s square equal s square is less than 0.1. So which is not quite possible or not common. Therefore you can say that Henry's friend claim is true. Or you can even mention that probably Henry might have made mistake. That too you can add it instead of this. Anything is fine because both are meaning the same thing. Let us start solving the third problem. A student wishes to estimate the proportion P of students at her college who have exactly one brother. She surveys a random sample of 50 students at her college and finds that 18 of them have exactly one brother. She calculates an approximate alpha percentage confidence interval for P and finds that the lower limit of the confidence interval is 0.244, correct to three significant figures. Find alpha correct to the nearest integer. So in the problem, we are getting the value of PS, usually proportion, and since in the formula we denote it as PS, so I'm writing this as PS. PS is 18 out of 50 students, so it is 18 out of 50. We can even write this as 0.36. So What is the lower limit which is given? So lower limit is given as 0.244. So in the confidence interval, what is the confidence interval, or which is going to be the lower limit? PS plus or minus Z into root of PSQS by N is what the confidence interval is. In this, if you apply only the negative thing, I mean PS minus Z into root of PQ by N, that is lower limit. PS plus Z into root of PSQS by N, that is upper limit. Since the given one is lower limit, it is going to be PS minus Z root of PSQS by N is what that lower limit is here. So I'm going to apply the values which is known here. PS value is 0.36 minus Z value, actually that is what we want to find it. So Z root of PS again, so 0.36 into Q is nothing but 1 minus P, which is 0.64. So 0.64 is Q whole divided by N is actually here 50 students. So it is 50. That is equal to 0.244. Now this part is having the unknown thing. So let us move this part to that side. So it becomes positive Z root of the simplified thing. What you will get for this is 72 divided by 15625. Then automatically this 0.244 we can bring it to that left side. So 0.36 minus 0.244. Then the subtracted value is 0.116. Then since we want to find out Z, this remaining part also we can move into that side. So it is going to divide. So it is root of 72 divided by 15625. That is what Z value is. So in the calculator I'm getting that Z value is 1.709. And when I'm finding the probability by using the table 1.709, actually we have to do, because we should know what is the percentage or what is the probability is to know the area. For 1.709 I'm getting the area as 0.9562. But here we are not supposed to conclude that the confidence interval is 0.9562, because it is a normal distribution. If it is normal distribution, it is actually a symmetrical curve and the confidence interval is in the center. It actually starts from the mean. It increases in both the right and left side. So 95% is purely there in the, it's not actually, that is what we have to find. The confidence interval percentage we should find, but it is purely in the middle part, not in the left end and then right end. But the Z value, what we are using for the calculation, actually it says that 0.9562 or 9562% is what it is giving. It means that we know it is actually exactly dividing off of. So if you know that, so this value, the left side value is exactly 0.5. If you subtract that, you will get to know this part alone. Which part? From the mean, what is the maximum, that alone you will get it. This part alone you will get to know. So from 0.9562, if you subtract 0.5, we are getting 0.4562 as answer. So this part alone 0.4562 in the sense that is nothing but one side of the confidence interval. So but confidence interval is twice because the curve is symmetrical. This value, if you multiply by 2, you will get the exact percentage of the confidence interval. So that area is 0.9124 we are getting. And 9124 in the sense, and in the problem they asked us to find out the value of alpha, the percentage of confidence interval. 9124 we usually write it as a perfect percentage. So alpha value is 91 here. Let me explain once again. In the problem, they are actually given that lower limit. They gave the probability P is proportion they have given, but they are asking us to find out what is the alpha value of the confidence interval. So the lower limit formula, I have it, I substituted and I equated with the given lower limit, and I just did some algebraic work here. I moved that unknown to the right side and I moved all the known to left side. Then after simplification, again I just splitted that z alone from the other thing. Then I'm getting the value of z from the for the z. What is the probability that I'm getting is 0.9562, and I know that the confidence interval is it is there in both the right and left side of the mean. So the left side is entirely 0.5. After subtracting it, I'm getting to know the right part alone 0.4562. When I'm multiplying by 2, I'm getting to know that the entire area of the confidence interval is 0.9124. Therefore, the alpha percentage is 91. The value of alpha is 91. So the next problem what we're going to solve is a fourth one. A random variable x has the distribution with normal. The parameters are 10, 12. Two independent values of x denoted by x1 and x2 are chosen at random. Write down the value of probability of x1 greater than x2. But the mark given is only 1, and then the space is also not provided. Like, it's not enough. I feel maybe when we are doing the calculation it won't be sufficient, but if we think what is the thing that we have to do, and for just for 1 mark we just find the mean alone, then let's see what is the answer it will be. Since it is probability of x1 greater than x2, we have to solve in a way that x1 minus x2 is greater than 0. Actually, this is the method that we will have to use it. The variables one side and then the rest another side. Since there is nothing, it is going to be greater than 0. So for x1 minus x2, if you find the mean, it will be 10 minus 10. It is going to be 0. So mean is 0. If the mean is 0, what will happen for the normal distribution? Already the right side value is 0. Mean is also 0. Then it'll become pi of 0 minus 0 divided by whatever the standard deviation, let it be. It's entirely 0. So pi of 0 is what going to be there in the numerator. Numerator in the sense entirely the value is going to be 0. So pi of 0, we know that from the table we can get to know that the value is 0.5. So that's why that space is not provided. That work, this problem actually gives you work for your brain. Maybe you don't need to write bigger. So we are finding the mean, it is 0. The value is also 0. 0 minus 0 gives us the entire numerator as 0. So the probability for 0 is 0.5. Let's solve the next problem, and let's use a similar method to solve this. As I said before, for solving this we have to bring all the variables to one side, and if you are bringing the value which is there in the right side will be negative. So what I'm doing is, let me move this minus 3 here and then x1 here. So it is going to become 2x2 minus x1, and since I'm switching the side, that greater than will become less than 3. You no need to do in this way. You can even do that x1 minus 2x2 also, but all the values will be negative just to avoid the negativity. I'm just doing in this way. So this is what the function that I'm getting. For this I have to find the mean as well as the variance. So the mean what is given here is 10 and 12. So for this, what is the mean that it is going to be, because both are from the same group. Actually x1 and x2 are x group. So mean is 2 times the mean here, which is 10, minus this mean, which is 1. So the simplified mean is going to be 10. Then if you see variance, I will have to square it because it's a function and multiplying 2 and something, so that I will have to square it. So 2 square it is. So 2 square getting multiplied by 12, because that is a variance, minus, actually if it is minus we will have to convert it into plus for the variance. And what is the coefficient of x1? It is 1. So if you want maybe 1 square you can put to maybe satisfy yourself, multiplied by the variance, again it is 12. So the simplified answer for this one is I'm getting as 60. So Now the normal distribution is 10, 60 it turns into. And actually that's it. If you see the mark, it is 5, but once you write the proper function and after finding mean and variance, this problem is actually nothing, because we have to solve this one. Actually we have to solve this and we rewritten like this. Now pi of the x value is 3 minus mean is 10 divided by standard deviation is root 60. So that's it actually we have to do. And this one is giving answer as negative, so negative now we will have to do like pi of negative 0.904 is what, because the calculated value is 0.904 is what I'm getting. Since it is negative, what we have to do, we should put 1 minus pi of 0.904, and this gives us the answer as 0.1831, and we can say that the three significant figure answer as 0.183. So in this problem what we are doing, we are rewriting the function into the solvable method for the solvable one. Then we are finding the mean and standard deviation for the function what we are getting here. After that, just applying the normal distribution thing, and it is quite simple. So the next problem what we are going to solve is the fifth one. The number of goals scored by a sports team in the first half of any match has the distribution of Poisson with the parameter lambda is 3.1. So maybe we can take the lambda of first half is 3.1. The number of goals scored by the same team in the second half. So let's write lambda 2, which is 2.4. And this has the distribution of x and this has the distribution of y. You may assume that the distribution of x and y are independent. Okay, they are independent. And the first subdivision is find p of x less than 4. So probability of x less than 4 we have to calculate. It means that we have to find the probability of 0, 1, 2, 3. Okay, it is x, means that we have to use this lambda value. So how we will write it? What is the formula for Poisson distribution? As you are aware, e power minus lambda, maybe that we can write it outside. 1 plus lambda square by 2 factorial plus lambda cube by 3 factorial, and keep going. This is what the formula that we have to use it here. Since they're till 3, we have to use this. So e power minus lambda values here 3.1 multiplied by 1 plus 3.1 plus 3.1 square by 2 plus 3.1 cube by 3 factorial. Why I have written instead of 2 factorial as 2? Because 2 factorial and 2 both are same, but if you want to satisfy, like, you can put even 2 factorial, not a problem. And just entering all these values in the calculator will give you the final answer, which is 0.62483 I'm getting, and the three significant figure answer is 0.625. That's it. This subdivision is over. Let's move on to the next one. Find the probability that in a randomly chosen match the team has scored at least 5 goals. It means that they want probability of 5 goals. Maybe let us take Z, and you are not supposed to get confused with why am I going to take Z instead of X or Y, because for the X is for the first half, Y is for the second half, and but here they did not mention whether it is first half or second half, and also they did not mention that whether it is X or Y, and but they told that the total entirely the team have scored 5 goals minimum in the sense. So I'm using X, but maybe since you don't want to confuse, I'm going to use W. So W should be minimum 5. So W is greater than or equal to 5, so I have to find. But in terms of calculation, probability of 5 and above, we don't know where it is going to end. So instead we can do prob 1 minus probability of 0, 1, 2, 3 and 4 if you find, and it will be the perfect answer. Instead of finding that, we will be finding this. But now W for the total match, what will be the lambda is going to be here for the first half and second half. A match is inclusive of first half and second half. For the first half it is 3.1, for the second half it is 2.4. So we are actually combining it, means that we are adding, so we are getting the lambda value is 5.5. That's what we have to use, and this problem is also simple. So 1 minus e power, the formula actually I have written it already here, the same formula I'm going to use it. E power negative 5.5 open bracket 1 plus 5.5 plus 5.5 square by 2 or 2 factorial plus 5.5 power 3 by 3 factorial plus 5.5 power 4 by 4 factorial. These are the values. When you're putting it in the calculator, we are getting the 3 significant figure answer as 0.642. 3 steps, 3 marks. So if you know that what to do for the Poisson distribution, then it is simple. Since it is a combined event of x and y, we are actually adding the two lambda values and getting the new lambda. That's what just we have to implement it. Let us move on to the next one. So the C subdivision is given that the team scores a total of 5 goals. So total goal is 5. In a randomly chosen match, find the probability that they score exactly 3 goals in the first half. So here it's maybe a tricky one, but if you actually write the problem clearly, then it is going to be nothing. They want a probability of in the total 5 goals. It's actually kind of conditional probability thing. So in the conditional probability thing, what usually we write is the denominator will have the total possibility, all the possibility we will write it, but in the numerator we will write the expected one. Okay, so what is happening here, that is given here, given that, so it is total of 5. So in the denominator they mentioned it 5 goals. Maybe you don't need to think in the like the previous one, at least 5 goals. It's not at least 5 goal, or it is not like x less than 4. It is perfectly, they mentioned that they scored 5 goals. So for the 5 goals, for the total thing, for the denominator, for the entire match, the lambda value is 5.5. And how many goals? Exactly 5 goals. So the denominator is going to have e power minus 5.5 multiplying with 5.5 power 5 by 5 factorial. Everything is 5. Why am I writing it in the denominator? Because the given one is going to be in the denominator when we are finding the probability. There are 5 goals in total. For the total, lambda value is 5.5. There are 5 goals, so this value, the x value is going to be 5. And what is the expected one, which is numerator? Exactly 3 goals in the first half. It says that the first half is 3 goals, in the sense definitely the second half will have the 2 goals. So the first half, first part will have 3 goals, multiplying by second half will have the 2 goals. Don't take this as the parameter as 3 and 2. It is just for your understanding I am writing it. For the first half 3 goals, second half 2 goals is what we are going to write it in the numerator. So in the first half, if there is exactly 3 goals, just like how we have written, the same thing we are going to do. For the first half, the lambda value is 3.1. So the formula is e power minus lambda. So I think you know the formula for Poisson distribution is e power minus lambda into lambda power x by x factorial for a particular thing. So e power minus 3.1 multiplied by 3.1 power how many goals? In the first half 3 goals by 3 factorial. Multiplied. Why are we multiplying? Because this is happening parallelly, and so 3 goals and 2 goals. So for the second of 2 goals we have to write that is again e power minus 2.4, because the lambda value for the second half is 2.4 multiplied by 2.4 power 2 divided by 2 factorial, it is 2.4. And that's it. If you write this, the 4 mark is in your hand if you're typing the exact thing in your calculator. So what am I doing here? Given that, so it's a conditional probability. We have to find the probability here. So in the denominator, the given option or all the possibility will be writing it. They said the total 5 gold. So for the 5 gold, the lambda value and exactly 5 gold, that is the thing that I have written in the denominator. And the numerator will have the expected one. The expected one is 3 goals, exactly 3 goals in the first half. So first of 3 goals and second of 2 goals. The two thing I'm multiplying, and these values, if I'm putting it in the calculator, I'm getting the answer as 0.34095 and keeps going. And my answer is exactly, it is going to be 0.341 because I should give the answer as 3 significant figure. Even if you see this, the writing what I'm doing is very minimal, and but we are actually getting the full mark. If you have any further doubts in like why are we doing like kind of things, maybe you can reach me out. I will give my contact number and the mail ID and other social media things also in at last, so you can reach me out and you can get clarified about your doubts. So the next problem what we're going to solve is the sixth one, and it is my favorite. The masses of cereal boxes filled by a certain machine have mean 510 grams. An adjustment is made to the machine and an inspector wishes to test whether the mean mass of cereal boxes filled by the machine has decreased. After the adjustment is made, he chose a random sample of 120 cereal box. The mean mass of this box is found to be 508 grams. Assume that the standard deviation of the mass is 10 grams. Test at the 2.5% significance level whether the mean mass of cereal boxes filled by the machine has decreased. Okay, so here the underlying things are the keywords, and this is also one of the keyword because we have to check whether it has decreased. So we are choosing the test which is one tail test. What is one tail test or what is two tail test? If you want the content specific one, you can mention it in the comment or you can just reach me out. So I will make the video of the content one separately so that from there you will be able to easily connect the problem solving on. Here we have to test this for the mean value has decreased or not. And let me go with the flow what I usually teach my students. It actually, the testing problem actually has three subdivisions. The first subdivision what I do is hypothesis. So I give a title that hypothesis. Since it is about mean, I usually write H naught. Null hypothesis is mu is equal to 510 grams, and we want to check whether the mean has reduced or increased. H1, the alternate hypothesis is mu is less than 510 is what we want to check. Okay, so the hypothesis is over. So the next part is testing. So when we are going to do the testing, so in the testing, the value what the tested for the sample is 508. So probability of x less than 508 is what I have to test. But you can see that the mean mass is found to be 508, means exactly. But why am I taking it as x less than 508? It is because the alternate hypothesis is mu less than 510, or you can even refer this one. We are checking whether the mean has decreased. If we are checking mean has decreased, we have to check x less than 508. If it is increased, we have to check x greater than 508. So in this case, it is x less than 508. So we are just proceeding the problems. 508, if you are solving, it is pi of x value is 508 minus mean is 510 divided by, it is for the sample. So the standard deviation what is given is 10 divided by root of, there are 120 samples, so it is root 120 is what I have to put. And I guess you're aware that the formula for normal distribution is x minus mu divided by sigma by root n, because that root n we have to include for sample. Whenever we do the sample, this is the thing that we have to do it. So in this I'm getting the values pi of negative 2.191 as the calculator value, and what I have to do is 1 minus pi of 2.191. The value what I'm getting is 0.0143 is the probability that I'm getting. Once I find that probability, the testing is over. Next we are going to the conclusion part. So the conclusion part is, what is the conclusion that we have to make is the probability what we got is probability 0.0143. We should check whether it is less than the significance level or not. So 2.5% is nothing but 0.02 0.00, sorry, it is 0.25. Accordingly, if you're checking, it is the probability is lesser, 0.025. It is lesser than that. In this case, actually the H0 is rejected. You may ask me the question, are we finding whether it is a less than of 0.025? It's because mean has reduced. It is not. Whether it is increased or decreased, we compare the probability value with the significance level, and it always should be negative, less than. It should be smaller than the significance level. Only in that case H0 is rejected. H0 is rejected in the sense the new claim what has been claimed is true. This is H0, this is rejected, and the true one is 510. So if the value is lesser, if the value is not lesser, then we will say H0 is accepted. So here there is enough evidence, because the evidence what has been submitted is enough. There is enough evidence that mu in the bracket, maybe you can write 510, has decreased. You can even write that similar words to describe the same thing. We are saying that there is enough evidence. H0 is rejected, it's because the probability is less than the significance level. So once the significance level is actually the test is passed, then we are making the conclusion that enough evidence are there to accept the new claim. So new claim is accepted and the old claim, the null hypothesis, is rejected. Then we are moving on to the next subdivision. Later, the inspector carries out a similar test at the 2.5% significance level using the same hypothesis and another 120 randomly chosen serial boxes. So here new sample, but still the significance level is same, the 2.5%. Given that the mean mass is now actually 506, find the probability of type 2 error. Okay, now let me tell you directly what is the probability of type 2 error is. Probability of type 2 error is nothing but 1 minus probability of critical region. So type 2 error the type 2 error's probability is nothing but 1 minus probability of critical region. So first thing what we have to do is we have to find what is a critical region is. How to find the critical region? What is critical region? So this part is what that critical region is. So we have to find what is the starting value for the critical region thing. That is what we will have to do, or else the entire probability we have to find it. So to find that, what we have to do is, first part what we are doing is critical region we are finding. This is the common step that we will be doing for all the probability of type 2 error problems. Also for probability of type 2 1 error we will do this, but not entirely. The critical region is common. How to find the critical region is, since it's a normal distribution, we are going to find the value, the x value we are going to find. Let us denote it as a here. What is the usual formula? X minus mu by sigma minus, it is a continuation of the previous one, so the mean value is 510. You can see here the mean mass is actually 506, but still we are in the previous part, the critical region part we are in. So what we have to do is we should use the previous mean here. So a minus 510 divided by 10 is the standard deviation which is given, divided by root of 120 again, like what I said in this. So the same thing we are doing it here, but the thing is there we use the value which is given, but here we have to find the value, and this is equal to what? This is nothing but 0.025. Why? This value should give exact the probability. Previously, if you see the probability we find for the given value and we tested whether it is less than that or not, but now we are finding what value will give us the exact significance level percentage. That is what we are actually doing. That is nothing but finding critical region. So accordingly, if you do, pi will go that side, it is pi inverse of, but if you see pi inverse of 0.025 is quite not possible, because the z distribution, the normal distribution, starts with 0.5. So actually here we have to inverse this, 1 minus this we have to do. So here also, to do the inverse, what I'm suggesting you is, let us switch the negative, so that is enough, more than enough. So 510 minus a whole divided by 10 by root 120 is, pi is going that side, it is pi inverse of the rest of the part. Since this is 0.025, so the rest of the part is 0.975. So we have to do for pi inverse of 0.975. So the pi inverse, whatever we are applying, it should be minimum of 0.5, only then we will be able to do it, or else again we have to come back to this. Now pi inverse of 0.975 is 1.96. So this is from the table, and in the bottom table specifically it is mentioned. Then I can move this value to that side, so it is 10 divided by root of 120, that is nothing but 510 minus a. Since I want to find out a, let me move this a to that side, and 510, let it be here, and I can move all this value to the side. So 1.96 into 10 divided by root of 120 is the a value. So when I'm simplifying, I'm getting the value is a as 508.210773. It says that if I'm using this value here in the problem, like how I used here 508, so if I'm using 508.210773, if I'm using it, I will be getting the probability as exactly 0.025. That is what we found it. But do we need this? No. We found the critical regions limit. Now we have to find the probability of type 2 error. So when we are finding the probability of type 2 error, as I said, we have to find 1 minus a probability of critical region. So what is the critical region? Probability of 508. So pi of 508.21, because after this 0, so we can ignore this. 508.21 minus, now when we are writing this, what is the mean that we have to use is the actual mean which is given is what we have to take it for consideration. Just keep that in your mind. For the critical region, the existing mean should be used, but for the probability of type 2 error, the given mean, the actual mean what is given is what we should use. So minus 506 whole divided by, the rest of the process are all similar. So root of 120, 10 by root of 120. So we are getting the answer as 1 minus pi of 2.421, and this is giving the answer as 0.0078. So this is what the probability of type 2 error is. If you see, maybe you can feel that I have written a lot for this problem, but actually it is simple. Whenever you want to find out probability of type 2 error, find the critical region in this way, and after finding a, for that find the probability once again. But if it is type 2, so let me also explain what I will do if it is type 1 error. I will not do 1 minus, that's it, I will not do it, the rest all are same. I will just find pi of 2.421, and there I will use the same mean. I will not use the new mean, because new mean will not be there for type 1 error. Only for the type 2 error, the new mean, the actual, they mentioned it right, that one will be given. So I will find that. So first thing is I have to find the critical region by using this method. Then the second thing is I have to find the probability of type 2 error, just applying the values in the condition. So we are in the last problem, and the probability density function. So we are doing continuous random variable. So the function is given as f of x is k into 1 plus cos x for the limit 0 to pi and 0 otherwise, where k is a constant. Show that k equal to 1 by pi. So whenever the variable is given and we want to prove that the value, or we want to find the value, it is a simple thing. We just have to integrate the given function for the given limit. It is 0 to pi, and then the function is k. I can take it out into 1 plus cos x. I have to integrate it, and I know the integrated value is 1 because area under the curve from this limit to this limit is 1, is what the main theory is. If you know this theory, the further solving is nothing. Now when I'm integrating 1, it is going to be x, and then cos x, if I integrate it, is sin x. Then integration has also become simple. Then after that, what I have to do is I have to apply that upper limit is 0 pi and then lower limit is 0. Then the integrated value must be 1. That is what we have taken it. Then let us apply the upper limit. When I'm putting this, it is going to be pi plus sin pi for upper limit minus 0 plus sin 0 for the lower limit equal to 1. Now k into pi plus sin pi is 0 again, minus 0 plus sin 0 is entirely 0 because 0 is also 0, sin 0 is also 0, that is 0, equal to 1. So now what we have is inside we have only pi. So k pi equal to 1 or k equal to 1 by pi. That's what we want to prove, and we prove. Okay, so the next subdivision B is verify that the median of x lies between 0.83 and 0.84. The first line what I'm writing is very important so that you can catch up the further thing easily. So median is what they gave, and they said they did not give us the exact value, but they are saying that the value is in between 0.83 and 0.84. Mean, how usually we find the mean? Mean starts with the lower limit is 0, the upper limit we don't know, that is what we have to find it, and we have to integrate the function. Since it is mean, it will give the probability as 0.5. It's similar to this one what we have I have written here. This one is because the entire area is 1. Since it is median, it gives the half area, so the right side value is 0.5. What is the function? It is k. Since we found the value of k in the previous subdivision, the same thing I can use it here. So 1 by 5 into 1 plus cos x. So the same function I have to integrate. I already have integrated this, so direct value I can be taking it. So x plus sin x is equal to, x plus sin x is the integrated value, upper limit is m and then lower limit is 0. This is nothing but 1 by pi is equal to 0.5. Now I will have to apply the upper limit and then lower limit. Since this we want to prove 0.83 and 0.84, it is similar to in the PM3 numerical solutions will be proving the root is in between this and that. So let us try the median as 0.83 and 0.84, and let's see what is the value we are getting. Okay, so the LHS part alone we are going to take it. I'm considering mean as 0.83. In that case what I will get is 1 by pi. So if the upper limit m is now 0.83, so it is 0.83 plus sine 0.83, and you know that if you put 0, the value will be entirely 0, so minus 0 you can put it. The value in the calculator what I'm getting is 0.499 I'm getting. Okay, it is lesser than 0.5. So obviously we can say that the median is after 0.83. Let us find the next value, which is 0.84. So when I'm substituting 1 by pi, the upper limit is I'm substituting it for x, which is 0.84 plus sine 0.84 minus 0 for the lower limit, because when I put 0 plus sine 0, it is entirely 0. When I'm putting this value in the calculator, I'm getting the answer as 0.504. So actually that's it. You can see that when I'm substituting 0.84 as a value, it is crossing the median, so median is before this. So we can say that therefore median is, or median lies between 0.83 and 0.84, because we won't be able to find what is the exact median here because of the x plus sin x. If you apply this m plus sin m, we won't be able to solve this. So that's why we are actually proving it. When we are substituting 0.83, it is lesser than 0.5. When we are substituting 0.84, it is greater than 0.5. So definitely the median is in between this, means the median is in between 0.83 and 0.84. Let's go to the next one, the last subdivision of this paper. Find the exact value of E of x. What is E of x? The general formula is the entire limit will be using it 0 to pi x f of x dx, means the function will be multiplied by x and that we will integrate it. That is what the E of x is. So let us do that. So the function is actually varying from 0 to pi, and 1 by pi, which is k value, x into 1 plus cos x. Because 1 plus cos x is the function, we have to multiply this with x. We have to find the probability. This is, we don't know what is the value that it will give. So that is our work actually here. So 1 by pi integral over 0 to pi. So the function is 1 into x is 1. It is not 4. It is 1. 1 into x is x plus x cos x dx. So when you are integrating x, what you will get, it is going to be simple. It is x square by 2, but x cos x. So what we have to do, the PM3 integration by parts, we should use it here. And we usually prefer for u x we will use it, for v dash we will use this cos x. It means that I'm just writing that also, maybe in a single term, you people try to catch up that. When we are integrating integral over uv dash, the formula is, when the value is uv minus integral over vu dash. So instead of integrating this, we will get this value. Means we are going to simplify things further. So that's what I am going to do for the second part. I'm going to implement that 1 by pi is the constant that I have. When I'm integrating x, I'm getting x square by 2. And when I'm integrating this, what am I getting? X cos x is not possible to integrate. So uv, what is u? It is x. So plus x is u. V, what is v? V dash is cos x in the sense. V is the integrated value, which is sin x. And also I want u dash. So if u is x, u dash is 1. So that's what I'm going to apply. uv. So u is x and then v is sin x. So x sin x minus integral over v value into u dash. U dash is 1 into v value is, v is sin x. And if you see now, integrating 1 sin x, that is nothing but sin x, is easy for us. The upper limit is pi and then lower limit is 0. Now just I have to go with the flow. 1 by pi x square by 2 plus x sin x. Sin x, if you are integrating, it is minus cos x. Since already minus is there, it will become plus cos x. This is the entire integrated function. Now I should put the upper limit as pi and then lower limit as 0. So 1 by pi, upper limit when I'm putting as pi, it is pi square by 2 plus pi sin pi plus cos pi. This is for upper limit. For the lower limit, if I put 0, this is 0. This is also 0 because 0 into anything is 0. Here cos 0 is 1, or I can even write cos 0. Now I should simplify it further. 1 by pi, pi square by 2. Sin pi value is 0, so this term, it is vanishing. And cos pi is minus 1, so minus 1 here. Then minus 0, 0, cos 0 is 1. So minus of 1 is again minus 1. So 1 by pi square by 2, minus 1 is minus 2. And let me multiply this pi inside. So when I'm multiplying, pi and pi square will get cancelled, so it will become pi divided by 2 minus 2 divided by pi, because I'm multiplying pi inside. So, and maybe you are not supposed to put these values in the calculator and write the decimal answer, because just look at here, they are asking exact value of e of x. It means that pi should remain as pi itself. So this is the final answer we are getting. So that's it, this is solved. Maybe you can actually, this problem is for 4 marks. I feel that it is insufficient because we will have to do the regular e of x. Other than that, we also have to use integration by parts. So maybe it has a little bit more work than the other problems, but still it is not like the difficult one, it is easy one. I hope you people have understood whatever the things that I taught, how I solved the problems. If I have to improve anything, maybe you can mention it in the comments, so I will improve. And if you have any other comments, you can leave it in the comments box. For the further videos, you can refer that what is a topic or what is a paper that I have to work out. You can let me know. I will definitely do it. So to give me suggestions or to get to know or giving like topics that I want to teach you for even personal tuitions or like the content what I want to do further, the specific content you want as a video, you can mention it to me in this mail ID, adolpsathish92 at gmail.com. To this email ID, you can actually send me the mail, or if you want to contact me over the phone, you can use this number +91. You can use it if you're from India, and you can use the country code because I'm from India. So mention it whatever you want, either in the comment box or here or to the mobile number. I will reach you definitely. Thank you.